In the previous videos we've been talking about the field where values can be actualized, and in this video we'll talk about what it is that actualizes these values. And we're going to take as our point of departure the fact that the values seem to be actualized according to rules. Especially this is clear if we look at particles. But if we define a rule as a pattern that things behave in accordance with, we can see that in a wide sense it's almost impossible to deny that things follow rules, because you could say, well, maybe it's not the strict rules they follow, maybe it's patterns that have evolved and gotten stabilized over time. Well, then that's a rule then, that they can evolve and stabilize over time. But what if you say, well, but maybe that's even a coincidence? Well, then it's a rule that things can happen by coincidence. So in a broad understanding of rules, you can't deny that things follow rules. They behave in accordance with certain patterns. But what physics tells us then is that it's much more narrow and precise. We have this handful of particles from the elementary or the standard model of elementary particles, where there is one field equation and for each particle. So it seems to be very strict rules that at least the physical particles are following. But then we can ask, why is that the case? Why do things follow rules, either in the narrow or broad sense? How should we understand this? Some will say, well, there isn't, it's just a coincidence, it's not more to understand. Others will say, well, there are laws of nature, something that makes things follow rules. And that's the debate that we're going to enter, the philosophical debate on laws of nature, which will then take us to what I'm going to call the actualizer, that actualizes the values in the field. But we'll start with the philosophical discussion of laws of nature, where there are typically three main views. The first says that the laws of nature are just coincidences, like if you have a bucket full of colored stones and throw them on the ground, you can see certain patterns that you can describe, and those would be then like the laws of nature. They are just random patterns. There's not something behind it making certain patterns occur. It's just random patterns that we can describe. And the best version of this view is called the Mill-Ramsey-Lewis view of laws of nature, that they say that the laws of nature are the best generalizations of descriptions of the world then. Instead of making micro description of every event, which would be extremely complex to describe the whole world, we see that there are some generalizations that we can make that are valid all over. So instead of describing how each object with mass attract each other, we can have the law of gravity, which is a generalization describing how all things attract each other. But that doesn't mean that there's something more behind it. It is just a generalization of random patterns, according to the Mill-Ramsey-Lewis view. The counter-argument, the main counter-argument to this view, is to say that it's too much order in our universe for it to just be a coincidence, because we expect from coincidences that they shall produce chaos, because there are so many more possibilities for chaos than for order. If you throw a billion dice in the air and they land on the ground, there are so many random and chaotic patterns that are possible and very few order patterns. So the chance is very small that you should get 1 6 1 6 1 6 or something ordered. The chance is very big to have something disordered. So it seems to be too much order, that there are so many particles that can be described so neatly with these equations without exceptions, that it should be that all of that should be a coincidence. So the opposite view is to be a realist about laws of nature, say that there are something that can explain the regularities, and we call them laws of nature. Even if you don't know how that works, we conclude that there must be something. There must be a cause of this disorder. We can't say that there is no cause, so we should say there is a cause, and it's the laws of nature. So, for instance, Tim Odlin is a philosopher of physics who is a realist about laws of nature. The counter-argument against this then is to say, well, what are these mysterious laws of nature? How do they work? So David Lewis, for instance, who defends who's the L in the Miller-Ramsey-Lewis view, says that, well, if you can't explain how it works, then it isn't an explanation. You're just saying a word, basically, laws of nature. But it's no point in coming with an explanation that doesn't explain anything. So that would be the counter-argument. Then there's dispositionalism, which is meant to be a kind of middle view, which says that, well, there aren't some external things called laws of nature that make things move certain ways, but things like particles, they have dispositions, and we can summarize these dispositions as laws. So, for instance, an electron will have dispositions for moving and interacting in these ways, and we can summarize these as laws describing electron behavior, even if there aren't laws saying to the electron you should do like this. It's just the electron doing it because it has those dispositions. Counter-argument to that position would be there are also laws that guide the whole universe as a whole, describing symmetries for the whole universe or describing conservation of energy and momentum, etc. And so it seems very strange then that one individual particle should have as a disposition to contribute to the conservation of the energy of the whole universe. When you have laws like that, what should be the trigger of the disposition? Usually we say that a thing has a disposition, but it must be triggered by something outside of it. So for instance, the vase has a disposition to be broken, but then for that disposition to be manifest, something must break the vase. But if it's the whole universe, what could be, or the whole world, what could be outside of the whole world to trigger the disposition? And how would that work then? Dispositions also become mysterious. My own view is to defend the realist view. I think that it's best to have an explanation for the regularity, even if we don't know how it works. It's better to say there is a cause, even if you don't know what the cause is, instead of saying there isn't a cause, when it so clearly seems to be a cause. One additional supportive argument then for the realist position against the two others is to point to the holism of quantum physics, which we'll talk more about later. But the point is that there are plenty of evidence showing that particles, when they are moving, they take into consideration also things that are happening at the same time somewhere else that influences how they move. So again, this seems to be very strange if that should be a disposition to care about what another particle does at the other side of the universe. And it also seems very implausible that it should be just random, that it's always the case that it always takes care or takes into consideration what happens to certain other particles at another place in the universe at the same time. There seems to be some overall system guiding how things happen. So that's another reason to believe in realism about laws of nature. But we don't know what these laws of nature are. I am calling it, using the term the actualizer for that which actualizes the values, even if we don't know much more so far than just that there is a good reason to think that there is something like this. And then I'll continue to discover more about the actualizer as we move along the videos. But so far, to summarize about the basic building blocks in general that I've been talking about for the last videos, I've said that, well, we have fields, and I believe that they can be summarized to this one fundamental field. We have values that can be actualized in points in this field, and we have something that actualizes these values, namely the actualizer. So these are then the three basic building blocks: the fields and the values and the actualizer. And this was just the first presentation, and then we'll talk much more about all of them in the following and continuing videos.